So let's say we have a data set and we want to talk about the distribution of that data or the distribution of the values. The first thing we want to do is just what's some of the language we're going to use and what are some of the big picture ideas. So we're going to start with qualitative descriptions. And so these are descriptions that don't involve numbers. They're just kind of describing it. Examples of qualitative description that are like more normal English would be big, small, fast, slow, stuff like that. So when we're doing qualitative descriptions, remember that a distribution describes how the measurements are arranged. So there's three terms or three categories that we're going to look at. And so they will be shape, center, and spread. So these are the three aspects that we're going to describe about a data set. And we can describe these both qualitatively, like we'll talk about in a minute here, as well as quantitatively, and that'll be what we study the rest of this unit. So jumping on into the first one, shape. If we're talking about the shape of a data set, this is kind of, are all the values close, like in one place? Are there multiple bumps? Is it symmetrical? Is it skewed, etc.? That's shape. So if we imagine a histogram, and if my histogram is roughly this shape, that's one shape. I could also have a histogram that looks something more like this, or a histogram that looks something like this, or a histogram that looks like this, or I could have something that's just a complete mess. It's, something like this. So those are all examples of different shapes, and there's language for this, modal, bimodal, skewed, stuff like that. But as we get into it, we'll kind of introduce that language going forward. Next, we're going to talk about the center, and this is just trying to basically answer what is a normal or expected value. And the center, there's a bunch of different ways to measure the center, but you can also just kind of qualitatively describe it. So if you have something like this, the center is, you can kind of point it out there. If I had something like this, the center might be, say somewhere like here. If I have something like this, the center is here. So this is all, basically kind of standard English when we're talking about center and what that word means. Next, spread. Spread is how similar the values are. So a data set that looks like this has much less spread than a data set that looks like this. So maybe there's the same number of things, maybe they're centered at the same place, maybe other things are similar, but the spread is very different. In this case, there's more values at this center peak. In this one, they're kind of spread out. Likewise, you can have some really extreme spreads like something like this, where there's no data in the center, there's no values in the center, they're really at the extremes. So this is kind of what we describe with spread. It's going to be linked to shape, but shape, as we'll learn going forward, is really about how these curves can be described, as opposed to, there is some aspect of how many bumps there are, but the spread can also describe aspects like this. Outliers, when we're looking at a distribution, you can also have outliers. So sometimes data sets have outliers that are very different values from the rest of the data. And what I want to point out here is be very careful about removing them, and we should only remove outliers if there's good reason. Either we know something about how the data was collected that leads us to believe it should be removed, or we've done some sort of statistical analysis that tells us it should be removed. We don't just eyeball it and say, let's get rid of that. We have to have a compelling reason that we can then explain and justify so that others that come and look at our data can say, okay, yes, I agree, or no, I disagree. I'll run the calculations myself with the outlier included. So that's kind of the basic idea, and then the rest of this unit, like I said, we'll get into how we can describe these things mathematically as well.